Intro to logarithms. So we talked about exponential functions last time, and that was a fun adventure. But maybe you're thinking to yourself, we talked about inverse functions at one point. I wonder what the inverse of an exponential function is. I'm certain you have that thought process. Um, so certain of that. And let me tell you, the inverse of an exponential function is what we call a logarithm. So remembering back, inverses swap those x and y values of the coordinate points of a function. They swap the x and y, so the y becomes the x becomes the y. Logarithms are what do that for exponentials. So a logarithm is a function that has a base. You can kind of see down here what's happening. It has a base. B has to be greater than 0, not equal to 1. These are the same requirements for the base of an exponent of an exponential function. So same requirements. It's denoted log base b of x. And let me just kind of write what we would say out loud here. This is log base b of x is what we would say. This b is a subscript, so it is slightly below the line of the word log. So when you're writing this in your own handwriting, I see a lot of students that'll like put like a b up here. That's not where the b goes. The b does go right down here. It's like the opposite of a superscript. Superscript is up here, subscript is down here. So log base b of x. And the way that we define this log idea, how this is defined, is this, if this is your exponential statement, this is what we call exponential form. Exponential form. If you have this exponential statement where you have a boom, a base, an exponent, and this, I guess, answer over here. That same statement in logarithmic form would be that log base b of y is equal to x. So if you have b raised to the x is equal to y, the same statement as a logarithm, this is the same base. That b right there is the base. The base of the exponential is the base of the logarithm. The input into a logarithm is the output of the exponential. And the exponent of the exponential is the output of the log. And this is logarithmic form. Logarithmic form. So if I wanted to make some equivalent statements here, if I said that 6 squared was equal to 36, which it is, this is a true statement, I'm not lying to you here. In log form, I could say the same thing by saying that log base 6 of 36 is equal to 2. This is saying if you take the number 6 and you want to make it into the number 36, you would need to raise it to the power of 2. It's almost like this asks the question, what do I need to raise 6 to in order to get 36? So there. So log base 6 of 36 means, what do I need to raise 6 to in order to make it 36? The answer is 2. Logs, output, and exponent. I can't say it enough times to to make it more important. You really just need to repeat that statement over and over again. Logs, output, and exponent. Logs, output, and exponent. Logs, output, an exponent. The output of a logarithm is an exponent. The more times you say that, the more it's stuck in your head, the better everything works. Just having in the back of your head the knowledge that logs output an exponent will save you a lot of grief. So important notes about logarithms. Logs output an exponent. There is a memorization trick, the loop-de-loo method. This trick is summarized as start at the base, across the equals, back again. You're going to hear me say this a lot. Start at the base, across the equals, and back again. And I'm going to move all these guys up. So this is the trick in order to change something from exponential form into logarithmic, or the reverse direction of from logarithmic into exponential. So here's how it works. We'll do one direction at a time. If you have y equals log base b of x, and you want to change this into exponential form, exponential form is going to look something like this. You have something raised to the something equals the something. And you know that the base is this guy right here. Right? The base is the thing that has the exponent on it. And the base of the logarithm is also easy to point out. It's that number right down there. So the loop-de-loo method says you're going to start at the base. I'm actually going to erase that. I need space here. You start at the base, right? B is the base. I'm going to put it in right here. B. B is the base. You start at the base. You go across the equal sign to the other side. So that's your next box that you're filling in, because I'm filling in all these boxes, right? B raised to the y, and then back again, is equal to x. So you're filling out those boxes. It's 1, 2, 3. B raised to the y is equal to x. And this works in both directions. If I say b to the x is equal to y, the way I'm rewriting that, and let's see, let's move you here and move you here, just a little bit of rearrangement here. If we have this guy, we're trying to fill in log base whatever of whatever equals whatever. This is what we're trying to fill in. So we start at the base of the exponential. The base is b. Base is b. So we filled in the b. We go across the equals. So this next box is y. And back again. This last box is x. In the next video, we'll be doing this memorization trick a lot in the converting exponential and logarithmic equations video. We'll be doing the loop-de-loo trick a lot, but that's the loop-de-loo trick. And the nice thing is it doesn't matter. It doesn't matter if you're going one way or the other. It doesn't matter if you're going from logarithms to exponentials or from exponentials to logarithms. It also doesn't matter if the logarithm is on the left or on the right, or if the exponent is on the left or right. It works every time. Start at the base, across the equals, back again. Again, check out the next video for more on that. Another important note about logarithms is that because exponential functions and logarithms are inverses of one another, they will undo each other. So if you remember back when we talked about inverses, we said that if you compose an inverse with the original function, they cancel out and you're left with just the input, so x, in either direction. So if we use the original function b to the x and we call the logarithm the inverse function, and you compose f inverse with f of x, you'll get that log base b of b raised to the x is equal to x. This is a really important property, and we will touch upon it a lot more next section when we talk about properties of logarithms. It's an important property. Here, if you were to compose the inverse with the original function, if you plug in log base b to b to the x, you get b raised to the log base b of x. Those cancel, and you get x. The last thing to comment about as our intro to logarithms is that there are two special bases. There are special bases where we don't write the base as a b. If we have base e, we rewrite it as ln x. That is what we do instead of writing base e. That is the natural base, natural logarithm. If we have base 10, we just omit writing the 10 altogether. So the common base is base 10. If log is written without a base on it, that means that it's a base 10 logarithm. So if you don't see a base written, it means the base is 10. Do you want to point important point? This is ln, not in. It is ln. Important point when you're typing, because if you're typing and you write in, the computer's not going to know what you're talking about. All right, so next video, we're going to talk about going back and forth from logarithmic to exponential form. We're going to do some graphing of logarithmic functions. It's going to be a good time. So I will see you in that next video. Bye.